still a bug, which will be fixed with the next update of Mars. We have already fixed it, but we are working here on an older version. You can solve this problem by just adding a name to the property description, and we just give it the same name. Rerun it again. And now we want to be sure that grass regrowth per step, this property is set with the value of 1, and it's working. But that's not that important, because with the next version of the Mars framework, this bug is fixed. Okay, but the same, everything works. The grassland layer now updates itself every tick, and we don't need such a construct like an agent which is just created as a singleton and then updates something else. So we can be pure in the way we want to model. So the model is fitting the framework. Okay, so this was the third part. Now we want to create a new agent type, grass. Let's say the grass is not only, like right now, the grassland layer is a raster layer and every raster cell holds a value, but maybe the grass might be more sophisticated than that, and it should also react on weather. So let's create a new agent. We put it also in our model folder. We call it grass. It implements the iAgent interface, and it lives as well as all the other agents in this model on the grassland layer. Now we have to implement the missing members. We need to have an ID, a tick, and an init. This ID can just be set with a new GeoID, and the layer can be stored probably. So we say grassland layer equals layer and create a property. So make it an instance variable, right? Sorry, this. This, create field, below. Okay, and within the tick, it should just grow. So we want it to have an energy, public int energy field, which is a property. The energy should raise by the grass growth per step. So let's say we also have here the property grass growth per step, and the energy is raised every tick. Okay, and when sheep want to access the grass, right, eats grass, then we don't want to access directly the raster value, but we want to access the sheep. So we need some kind of would need to access the grass, and would say like get grass for our current position, and then eat like 3. This is old. Okay, create a method. Here we want to provide as return value the grass, and now our grassland layer should provide access to the grass. And we will make that quite simple. We will create for every cell that we have a grass and store all that maybe in a two-dimensional array, which we call grasses. So this is new grass array width and height. Create the property. And now we want for every cell, so for the width and for the height, we want to create a new grass agent and store it. Store this grass agent in our array. So to provide the grass back, we just access our array. Say position X and position Y. And because these are doubles, but we know that the positions, that's because the position object only has double X and Y here are double values, stored as double values, but in our case, we know they are just integers, so we can just cast them. In your case, you have to check if a cast is possible, but let's do it like this for a moment. Okay, so now the sheep can access a grass agent, which is on the same position, and then it should be possible to eat something. So in the grass agent, you see we now have this eat method, and it might return the energy. So let's see if we have enough energy. Or let's say in the beginning it returns all energy. We say energy is 0 and the result is returned, something like this, right? And later you could say, okay, how much should be eaten? Whatever you like. Okay, and here, of course, we want to raise our, so this is our grass value. This is not necessary anymore, and our energy should be raised by the amount of grass we have eaten, or the energy of the grass agent that we got. Okay, this is all model perspective. The C# programming, probably not so interesting for you. More interesting is the fact that we have a new agent, grass, and that we created it here in the grassland layer by just calling the constructor. But our grass has information that might be defined in our config. So we could, for instance, say we add here a new agent mapping for grass. We don't specify the instance count, but we want to say there's an individual mapping and new individual mapping, and the name is regrowth, and the value is 1, for instance. So this information has to somehow because you want to define something like this in your config and change it later when you run the simulation different times with different configurations. So how do you get this information, which you define in your simulation config, into your model? And for that, it is handy to use not create the grass by yourself, but to use the agent manager for it, which is inbuilt from the framework, a manager which helps you to create agents. Like you have seen here already, it creates all the sheep and all the wolf automatically. Okay, so we can also use here the agent manager to spawn grass on the grassland layer. But we always want to only create one. And then we say first. So you always need this terminating call, because that's the result of the spawn is the stream. That's the grass we want. This might go. So the agent manager automatically initializes the grass with information which is available. So if we would have here different properties, then the agent manager would try to resolve these dependencies. And it also calls automatically these finalizing init method, where you can finalize your initialization. Okay, and if you want to also add more information, which is only available here in the model, not in the config. So for instance, it's interesting for the grass to know the initial value, because remember, our raster layer has already a value, initial value for the grass in the beginning. So we could say, oh, this init value is what we have exactly at this raster position. And we want to have this information also in the grass agent. Then we can, with the creation, so it should be also available for spawn in the next version, but in this version, you have to use the create method. We don't have further dependencies. I say null, but now I can hand over a delegate, and this delegate, I can use that for assigning. I say, for instance, initial init value is init value. Okay, the init value is not there right now in the grass agent, so I create it. And now I would expect when we create, let's make a breakpoint here, that the init value is handed over. Okay. Because we use create and not spawn, we now are responsible for also registering. That works like this. We have again a lambda expression where we call the register agent handle. We invoke it